welcome back to my channel. I hope everyone is doing great. My name is Ravi Teja. Let's solve 13th problem of dynamic programming study plan, longest palindromic substring. Given a string S, return the longest palindromic substring in S. Okay, what is mean by palindrome? Palindromic. A string is palindromic if it reads the same forward and backward. Okay, if you see BAB and if you read it from the reverse direction, it will also be BAB. Okay, even after reversing this particular string, if we receive the same string, then it is known as palindrome. Okay, now given as you have to identify the length of the longest palindrome. Okay, in this particular string, BAB is the longest palindrome which can be formed. Okay, in this particular string, BB is the longest palindromic substring which can be formed. Okay, so idea is to identify whether a substring of the given string is palindrome or not. If it is a palindrome, we have to keep track of maximum palindromic substring. Okay, so let's say f of I comma j will tell whether the substring from I to j is a palindrome or not. Okay, if it returns true, that means it's a palindrome. If it returns false, that means it is not a palindrome. Okay, so I can actually break this problem into sub problem. Okay, so I can compare the character at I. If the character at I is equal to, if it is equal to character at j, then I have to check whether I plus 1 till j minus 1 is palindrome or not. If the last characters are same, then if the rest of the substring, if it is also palindrome, then the entire substring is palindrome. Okay, now this is the recurrence relation which we have written. Now let's look at the base cases. Okay, if I only have single character, okay, that means standalone single character is a substring. Okay, if I is equal to j, that means it's a substring. Let's say we have bb. Okay, when we are comparing bb, I s of I is equal to s of j. Now both the pointers will exceed each other. Okay, even in that particular case also we have to return true. Okay, when I is greater than j, that means we have encountered a substring whose length is 0. Okay, so this is the recurrence relation, right? So if we have recurrence relation, then we can straight away code it out. Okay, but you will notice that there are certain problems which will be overlapping. Okay, so whenever we have overlapping sub problems, we will be using dynamic programming, right? We will be caching the values which were already calculated, and then we will be reutilizing out. Okay, so the problem statement boils down to generate all possible substring indexes and then check whether each of them is a valid substring or not, right? So as I mentioned, there will be certain overlapping subproblems, so I need a DP array, right? So I just defined S and N as part of my class variables, and then I allocated them. Okay, where S is the string and N is basically the length of the string. And so we are basically generating all the substrings, right? Substring indexes. So I need a DPR of size n by n, and by default the maximum substring length will be, I'm taking it as 1 because standalone every character is a substring, right? So the default maximum length of the substring is 1, and then I'm just generating all possible substring indexes. Okay, for a given I, I'm taking j from I equal to j from I to n. So this way I can generate all possible substring indexes, ij values. Okay, so now that the dp of ij will be equal to f of I comma j, where dp of ij will tell me whether the given substring from I to j is a palindromic or not. Okay, if the string from I to j, if it is palindrome, then we have to maximize the length, right? So if it is a palindrome and the so far calculated the palindromic length, if it is less than the current length, then I will be updating my answer. Okay, I will update my max length to j minus I plus 1 and start to I. Okay, once this entire loop is done, then we will be having the start and as well as the max length. So my substring will be, my palindromic longest palindromic substring will be from start to start plus max length. Okay, now let's also look at f of I comma j. Okay, we just need to implement this recurrence relation, right? So when I is greater than or equal to j, we have to return true, right? For rest all other cases, I have to compare the characters at I and j. Okay, and then I have to get the answer for the remaining sub problem. Since there will be overlapping states, I will be caching those values. If the answer to a particular sub problem is already calculated, then I will be returning it, or else I will be computing the answer. Okay, if you submit this problem, if you submit this solution, all the test cases will be passed. Okay, let's also analyze the time complexity over here. Okay, so as you can see, we are populating this entire DP array. Okay, so the time complexity will be big of n square and space complexity also big of n square, right? So can we do anything better than this? Okay, it turns out to be we can do better. Okay, so what the second approach is, basically at any given index I will basically check whether I can form a palindrome of even length and odd length. Okay, so in order to form a palindrome of even length, I will start from this particular index and the next index. Okay, in order to form an even length palindrome, I will be taking two of the characters as my uh, middle characters for my palindrome, and then start expanding in both the directions. Okay, if you see b comma b is a palindrome of even length, so if I can expand this palindrome either if the next two characters are same. Okay, so this way I will be expanding the length of the current palindrome and try to maximize it. Okay, so as I mentioned, I will at any given index I will be checking whether I can form an even length palindrome or an odd length palindrome. Okay, if I can form any one of these, okay, then I will be trying to maximize my result. Okay, let's look at the palindrome function. Okay, what it does is, as I mentioned, I will start at the particular index I comma j. If the characters at I comma j are equal, then I will increment uh, decrement my I pointer and increment my right pointer. Okay, so that is what I am doing. As long as I am within the bounds, okay, within the bound, if the character at I and j are equal, then I will be updating the max length, and also I am storing the current palindromic substring in my result, and then decrementing my I pointer and incrementing my j pointer. This way I will be expanding in both the directions. Okay, and then my result will be storing the maximum palindrome. Okay, at a particular given index. Now we have to repeat this process for all the indexes from I to n, and then update my result with the palindrome which has the highest length. Okay, even if you submit this approach, all the test cases will also be passed. The time complexity in this approach is also order of n square, because for every possible index we will be expanding in both the directions. In the worst case, you will be expanding to till left and right. So time complexity will be order of n square, whereas space complexity is big of 1, because we are just using some variables and then expanding in both the directions. Okay, so space complexity is constant, which is big of 1. The second approach is little much better in terms of space complexity, right? Both the approaches have the same time complexity. Okay, if you like the explanation, hit the like button, hit the subscribe button, and also share your valuable feedback in the comment section. I will be posting solution in multiple languages in the comment section as well as in the description. Feel free to check it out. Thank you.